I think you're muted.
Yeah. So, bom, pessoal, estava muted. Obrigado por todas as pessoas que estão aqui nos assistindo. Estamos aqui no mais uma live do canal da NHibernate Code. E hoje estamos aqui com um convidado muito especial, o Ayende, tá? Como a live vai ser em inglês, eu vou mudar aqui para o idioma inglês, ok? Hi everyone, I'm thankful for all the attendance here, and it's a big pleasure to have Ayende here in the NHibernate Code channel, sharing his knowledge on RavenDB. So today we will be taking on a trip through the new great features that RavenDB has released in its latest version, in this case 5.0. And for those who don't know who Ayende is, he is a very known person that the development community in the development community due to his blog posts focusing on development best practices, and he has a lot of contributions to evolution of NHibernate, for example, and Ayende also has been building and evolving RavenDB during all of this time, right? I have met RavenDB about 2015 when I decided to give a presentation about ASP.NET identity using RavenDB as a NoSQL database. It was a big challenge for me because I didn't know nothing about what RavenDB is at that moment. And after that presentation, I have been following all the releases and RavenDB evolution. So just to finalize this introduction, I would like to share the experience of using RavenDB in a production environment. I have a friend of mine that is participating in a project that is migrating a legacy system that is using SQL Server, and he decided to use RavenDB as a database. For a few months, he shared a good feedbacks about the decision, because all the team members are feeling very comfortable using this database due to the friendly way of using all the tools on the RavenDB ecosystem. So here, Ayende will show us quickly how can we use RavenDB on the cloud and its management studio. It's a great tool. And after this introduction, Ayende will be focused on demonstrating to us the new features on RavenDB 5.0. And obviously, what are use cases of these new features and problems that these new features help to solve. So thank you so much, Ayende, for being here in this presentation in our channel. And the stage is yours. Feel free.
Thank you. My name is Oren. I've been working on this for the past 12 or so years. The reason RavenDB exists is that I was heavily involved with databases, with building data-driven applications, the whole 9 yards. And the key issue for many users, for many of the people that I work with, was that the level and the complexity of their system exceeded what they could do with a relational database. And I would come and I would look at what they were doing, and they would struggle with whatever it is that the database was doing. And I really wanted to fix that. And I would go from a client to client and try to fix that. And it was horrible because I would always end up fighting the database. And what I dreamed about was a database that I wouldn't have to fight. And this is how RavenDB actually came into being. At the same time, just to give you some idea, I'm talking about 2007, 2008, the state of NoSQL databases was effectively full of sharp knives. If you typically didn't have transaction, you didn't have anything to rely on, which was pretty horrible. And I wanted to create something that is ASCII, that has transaction, that you can just work with, all of the comfortable use cases of a relational database without all of the pain. Now, Today, RavenDB is 10 years old. It's we actually celebrated the 10-year-old birthday in May this year. And you can use it either on premise, on your own machines, anything from a Raspberry Pi. I actually have a Raspberry Pi 3 here that is running RavenDB to cloud machine and things like that. I'm actually going to use for the demo the RavenDB cloud instance. I'm going to run a cluster from Paris, and it's just going to be a small little instance. I like doing those sort of thing live, so you get some idea about the kind of experience that you can expect. So what I'm actually going to do right now is to create this instance. This is going to go ahead and create a RavenDB cluster in the cloud while we are speaking. This typically takes about 2 to 3 minutes. I'm going to assume that you know absolutely nothing about RavenDB. I love it when people ask questions. That's the best thing that can happen, because then I have interaction. I know how to guide things. I know where to go and all sort of stuff like that. The key thing from my perspective, and the main reason that RavenDB even exists, is that you need to be an expert to build proper databases. The problem is that the amount of things that you have to juggle as a developer to build modern application is huge. Anything from responsive design to appropriate distributed behavior, containers, Kubernetes, too many things, too many stuff. And in many cases, what ends up happening is that something has to give. That something in many cases is the backend. Okay, we will get by, we will get things done and fix it later. But the fix it later process end up being incredibly expensive down the line. And in many cases, it happens that, okay, my system is running, it's operating, we're starting to push data into it. And as the system grows, we're starting to see the pain in the seams. And one of the things that I aim to do when building RavenDB is to reduce as much as possible the amount of complexity that you have to deal with. And that means complexity in all aspects. For example, let me show you some code while we're waiting for this. Here is some code using RavenDB. We're going to need to provide some URLs, so we know we actually have the URLs already. I can put them in while we're talking. And the pattern is pretty obvious. And it's still waiting, it's starting. Good. Now, notice what we have here. I'm saying this is the database name, this is the URL I'm using, I'm initializing, and then I'm just going to write some code. Let's go ahead and store a new user. Apparently, I don't like birthday. I just thought that. I wasn't born today. Now, a few key things about this thing. There is nothing behind the scenes. The only thing that I actually had to do was go ahead and install this NuGet package. And now I'm ready. Now I can start working. Notice that I just created a plain old C# class. I didn't have to jump through hoops, no attributes, nothing. Store it, save it, run. If you're familiar with Entity Framework or NHibernate, this is very similar, except that there is no schema, there is no intermediate step. Now, this is done, and we have a system running. In order to authenticate against this system, I have to use a certificate, an X509 certificate, which effectively create mutual authentication between client and server. And I'm just going to set this up, and here is my certificate. I'm going to install it locally. This is so the browser will allow me to authenticate. And let's go here and set this up. And I wanted to use this certificate. That's good. Still need to create a database. Let's go here. I'm getting this window, authenticate as whoever you want. This is the first thing that happens when you start RavenDB. What's interesting is you can see that I'm on node A. We actually have a cluster. Now, we are currently running in AWS in the Paris region, and we have 3 nodes that are all deployed to 3 different availability zones. You can see it here. It's not really that interesting. Some did. Let's go ahead and create a demo database. Notice that this is a replication factor of 3. So we actually have replica, automatic replica between all of the nodes and high availability and all of the usual stuff. Right now, we don't care. Let's write the very first piece of code. I'm going to run this. And it's running, connecting, authenticating, and this is just end. Nothing happened. And then I'm going to go here. This is something very interesting. Here is my data. It's just here in front of me. This is not impressive. That's the key thing. This is not impressive because I haven't actually done anything. I have, what, 20 lines of code, excluding all of the white space. But if you think about it, what happened if you needed to create a new project in any other system? Okay, if you're using a framework called force, okay, connection string and set it up, and I need to make a whole bunch of decisions. What's the table name, conventions, all bunch of stuff, and it just works. You know what? I don't actually like this. I need to add some more properties. Let's say I'm going to, again, go ahead and run this. And here we go now. Here's the email. Notice the things that didn't happen. No schema, no mucking about with how things work, none of that. I can just get started. I cannot get working. Oh, sorry, that's an experiment that I'm running. So I just get to work with zero hassle. Now, interesting, you can see here that it says C. This is because I'm actually running this in a distributed environment, and the node that is currently responsible for this database is C. I'm actually running a node A here. Let's go and look at node B. So I actually have a full replica of the information. This is because RavenDB is a distributed database. I'm making it right in one end, and it shows up in all of the nodes in the system. Now, other things that are actually quite interesting is that, okay, I'm able to save data into RavenDB. Let's see what happens when I want to query that information. So session.query. Yes, it would really help if I was able to properly spell. This is a very, very bad query, but you know what, let's go with that. Now, the interesting thing about this is that I'm running a query, and I'm getting a result. By the way, this is interesting if you think about it. What kind of query did I run here? This is an email which in one of the documents that I have does not even exist. This is not null here. There is no email property. So what you can see is that we actually have a schemaless system, but a schemaless system that I can query. In fact, let's do this. Let's see what we have here. What is user? Because this is a query. And this is an interesting query. Let's go to the queries and run this. And we get a result. And that's interesting. That's interesting that we get a result. Why is that? Because I'm just running a query. Now, if I have one user, or in this case, two users in the system, that's nothing. That's not really even worth talking about. Let's see what happens when I have some more details. And we're going to create the Northwind sample dataset. And the Northwind, if you're not familiar with, this is an online shop. We have things like employees, customers, orders. It gives us a lot more flexibility in the system. So let's look at employees. And we have JSON. All of the data in RavenDB stores is JSON. Well, I tell a lie. Not all data. What do I mean? For example, what happens if I have an employee photo? Like here. This is actually stored as an attachment, just like an attachment on email. And here is Laura. So here is some binary data. You know what? I'm actually very interested in this Laura. And I have a time series about her heart rate. So it is the heart rate of this woman over time, which means that I can plot it. RavenDB gives you the ability to store a whole bunch of information. In this case, I'm showing you time series. Previously, we saw the document structure, the attachments. Here we go. Let's go look at a more complex system where you have, in this case, what you see here is we have an array, complex data structure. For that matter, I can also go back here and look at the changes in the data over time. I can see revisions. So this is very similar to what you see when you work with Git or SDN or something like that. The data doesn't just change. There is a record of all of those changes, when they happen, how it happened, all of those sort of things. So depending on the mode that you're running with, you have a lot more information to go with. Now, we also have the notion of counters. And in here, you can see that I have stars. By the way, this is me cheating. This is just an emoji character. So this is just some name, and we can increase the value. 100 or something like that. Now, or in this case, that was 3. So someone really doesn't like whatever this thing is. Now, why do we have a separate way of doing a counter? Why not just something like this? Again, by the way, I'm abusing the fact that this is just a character and a Unicode character. What's the difference between this and this? This is external to the document, which means that I can update that on multiple locations at once. For example, let's go to Node B. Let's try to create a race condition. I'm going to update the 2 stars on 2 nodes at the same time. 48 and 48. Let's see if I can create, and I'll update that in 2 locations as quickly as I could. Remember, this actually sits in 2 separate servers running in separate regions. So sorry, separate availability zone in the same region. But this is actually gets stored independently. So here is the This is the original value. This came from a different server. Now I added 1 and 1 in node A and node B, and this gives me the total tally. So the idea here is that if I have something that changes frequently, and the case of ranking a product, it's very likely that I have two users that are going to give a ranking to the product at the same time. So counters allow me to really point a multiple users at the same time to modify the same counter value with no concurrency issue, no distribution issue. If I modify the same document, then I'm going to have to synchronize on that, make sure that two users are not going to update at the same time. This is hard and complex. By moving that outside, I'm making things easier for me. Same thing here when I'm adding attachments. I don't need to think about, oh, how do I store that? I have a dedicated way of doing that, which goes across the board. By the way, this is also transactional. I can have a transaction that modify a document, add some binary data, add some time series details, all as a single transaction. Now, I started talking about queries, and I started talking about the queries when I'm running a query, such as this is a very simple query. If I have few results. Now, in this data set, the biggest collection that I have is orders. So let's look at my orders and let's try to ask orders grouped by ship to country. And here's some details. But I noticed that this query took some time to run. That kind of sucks. But you know what? It's currently running at 131 milliseconds, but the amount of data that you have is minuscule. Let's fix this. What I'm going to do now, I'm going to increase the amount of data that I have by a factor of 100. So for each document in the order collections, I want you to create 100 copies of it. And I'm actually doing that on node A, and let's look and see how it looks from node B. I'm pushing quite a lot of data here. And the amount of documents that I have, now I have 31,000, and in a few seconds I'm going to have more. You know what? This is taking too long. Let's make more documents. So I have another process running that is running on 56,000 and creating a few. As you can see, I'm pushing data. Okay. While this is running, let's go here and run the query again. Previously, I ran it with 830 orders. It took 131 milliseconds. I'm going to run it now, and it's take 31 milliseconds. And you know what? This is somewhat of a mess. Let's do this again. Giving them by order. Now it takes 79 milliseconds. And the more that I run it, the faster it becomes. This is one of the most interesting properties of RavenDB. The more you run a query, the faster it becomes. Why is that? Because RavenDB learns. It learns about the kind of things that you're doing. Now, let's see here. I can see that here we have Portugal with 2,000 orders. Let's run this, and this takes time. Notice, by the way, that I'm overloading the system. I'm replicating to 2 other nodes. I have quite a lot of writes. I'm doing indexing. This is 2 cores and 4 GB of RAM. That's not too much. And it took me 16 seconds to run this. And you know what? Let's try. What happens if I try France? is also taking, oh no, that took actually 1 millisecond. Most of the time was just spent rendering. Let's see what happened. And this is what actually happened behind the scene whenever I run one of those queries. Indexes were created. In particular, notice that here is an index, auto index for by ship to country. So now when I make a query, instead of this taking 16 seconds, it takes me milliseconds. And query on Portugal again, milliseconds. You know what? This is when I'm asking about a country. Let's say that I want this to check on city. I have no index on this. So this is going to be stored. And again, this is going to take under load about 15 to 16 seconds to run. This is when I'm going to cut and give you whatever I have. And in a few seconds, we're going to see it now. By the way, notice we are still writing. We're still pushing data into the system. Here are the results. And we can actually see it here very nicely. Here is auto index by city. And here is by country, and city and country. Now, this is really, really strange. Why do we have for both of them? And the answer is that RavenDB did this. Here is the first index. It's only by country, and it's running. It's catching up with all of the writes that I'm running. But we also have another one by city. So until this one catch up with this thing, we're going to maintain both of them. Once I'm done, and I think that I have enough orders now, I don't need the 5 million that this would create. Once I'm done processing all of this, RavenDB is going to say, hey, wait a second. This index can answer any question that this index can. So why do I bother maintaining that? And this one is going to get cleaned up. By the way, you can see that once I remove the load of all of those writes in the background, the indexing speed is starting to pick up tremendously. And this is another features of RavenDB of automatic load balancing inside the system. The more work I have to do in the front end from the point of view of RavenDB, answering queries, handling insert, those sort of things, background work such as indexing documents get less resources. Now you can see that the country one is done. All of the queries on country will now use this index. All of the queries on city will use this index. Once this one is done, this one will go away. It's going to take me a few seconds yet to do that. We're currently on 386,000 documents. So not a huge amount, but a significant amount nonetheless. Now, what does it mean that we have automatic indexes in this manner? What it means is that as a user, I don't need to think about that. Remember that I wrote this query? I just wrote a query and ran it and got results. Remember, I did this, got results. Let's look at the demo database for a second. Here is an index that was automatically created by RavenDB when I issue a query. This is because when a query goes to RavenDB, it's not, oh, I have an index, I will use it. I don't have an index, I'm going to do a table scan. We are going to analyze that and create the appropriate set of indexes. The more that you query, the faster things become. Because we give RavenDB more information. Now everything is a match. And in a few seconds, this one is going to go away. I actually added a delay manually. And there is a demo, there is a comment there for the demos. And it went away. Because otherwise it would happen too fast for me to talk about this. Now, what are the impacts of doing things in this manner? Well, it means that a lot of the overhead of working with RavenDB is gone. We don't need to worry about the schema. We don't need to worry about what's going on in the system in terms of, oh, what queries, how do I optimize, those sorts of things. All of that happens for me. For that matter, remember that I ran a query using a GroupI? This takes 0 milliseconds to run because there isn't the load of doing all of the inserts now. But how does it work? How come I can get 0 milliseconds querying on almost 400 items? For that matter, let's go and start adding more items again. We're just going to let it run in the background and see how much it's going to take now. And again, almost no time. This is because we have the concept of a MapReduce index. A MapReduce index allows me to run aggregation. In this case, do some count by the ship country. Let's go here and see what this means. What this means is very simple. I'm going to run the query, but instead of querying over 4,050,000 documents, I'm going to go over here and map them. Here are all of the documents from France. This is one particular document, count of one, country of France. And now I have a summary. In this location, I have 992 items. I have 62 other items like that, and then I have almost 50,000 orders for France. What this means that when I'm querying, I'm seeing it here immediately, on the spot. And I don't need to go and look at this value. I can go ahead and look at this value, and this is effectively instantaneous. What's even funnier is that the more data I have, the faster things become. Now, why is that? It's because the more data I have, the more efficient things become. Let me just show you how it works. We're going to go back here and try to understand what's going on. This is a tree. So right now I have 73,000 items. I added more items here. So what actually happened, whenever I add a new order for France, I have to go here, edit here, update this value. By the way, this happens on the other side of the tree, but the same concept apply. Update this, and then update this and this. The bigger the data set that I have, the bigger the tree, the wider the tree, and eventually it becomes multi-level. The typical multi-level happens once across the 10 million, 20 million items here. And now I have to update 1, 2, 3 items, and I'm done. If there are an order of magnitude more items, I have 1, 2, 3, 4 items, then I'm done. It's OH, where H is the height of the item. OH. Or in this case, O log of N, with N is this number. Ridiculous. And when I'm querying the already pre-computed values. Now, this is fun and all, but then we start talking about other queries that I can make. Let's look at this. Here are products. Here are some products that I have. Now, let's find all of the sources. Here are the sauces. Cranberry sauce, hot pepper sauce. And that's really interesting. That's interesting because what do I have here? I'm doing full text search on this property. You can actually see it very nicely here. How we have the names, and we have the full text that allow me to do all sorts of interesting things. Now look at this. I'm going to search for Fantastica. But if I'm spelling that without this line, which I'm not sure how you call it, I'm not going to get it. But what happens if I do something like this? I'm asking really, hey, I'm searching for this. Give me this. What am I searching for this? Still give me the right thing. It gives me the ability to understand exactly what's happening in my system. I can ask RavenDB questions, not about just my data, but other related stuff. Here is another good example. I have employees. Employees have some nodes. You know what? Let's search for Dallas. Okay, so apparently I have some Dallas here, but it's kind of hard to find exactly this thing. Again, let's ask RavenDB to make our life easier. Notice here that I have the highlights. You can actually see that we pop it out for you. A lot of the features that RavenDB has are meant specifically to make life easier. Now, I'm focusing on queries because they're easy and fun, but there are other things that I can do that are much more powerful. For example, I mentioned that we have MapReduce indexes. Here is a MapReduce indexes that I define in code. This is link. You can see that I do some summary. Here is the total per order. Now I'm grouping everything by company and give you the totals per company. Here are the results. Again, the results are instantaneous. So I'm able to run non-trivial computation without any real work. Now, the more interesting thing that happen is that I'm able to run this. And again, just like we saw before with the MapReduce, everything is happening, everything is computed. You can see here, by the way, RavenDB here, this is expensive because we're using spatial queries. Now, what I'm going to do something very, very simple and relatively stupid. I'm going to just write some code in a loop. Back a bit. So what you can see here is that I'm just writing documents in a loop. This will shortly start printing. The first one is going to be quite expensive, but then you can see I'm speaking to you from Israel. You can see here that this is about 70 milliseconds. That's the ping time to Paris for my location. Now, why am I doing that? First of all, let's understand where we're at. We are now talking about, sorry, this thing. We're now running, and the primary node for this document is node A. We're in the demo. We're writing to the demo database. So the primary node that we have here is node A. You can see it here. Previously, by the way, it was node C. The cluster decided to change that. I'm going to do something. I'm going to force us to restart node A. In a few seconds, this one is going to go down. Okay. What about this thing? This keeps going. You can see here, oh, we had an error. We recover, we move on. Notice that I have 0 error handling code here. But if we go here and look at the databases, now node B is the important one. Is the first one in the list. Node A is currently failed. The cluster automatically detected and recovered. There's been nothing for us to do as a user. For that matter, let's say that I'm noticing that the system is under load. It's not. It's properly handling. But let's say that, you know what? I'm going to try to put more load in the system. Let's do this multi-threaded. Here we go. The joy of multi-threading unsafely. Actually, this is safe, but still, you know. Wait all. So what I'm actually doing here, I'm spinning 8 concurrent tasks and telling it, just go ahead and run. We actually don't even need this. So let's run. And when they fail, we're just going to let it run. My hope is that this will put enough load on the system that we can notice that. By the way, what I'm doing here is not the right way to actually import lots of data. There is a dedicated API for that called bulk insert. But you can see the system is running. We are doing about 100 tries a second. Not that interesting. But notice that RavenDB is handling that with equanimity. Nothing really that interesting for us. But I want better system. So I'm going to upgrade myself from, let's say, to 4 cores and 16 GB of RAM. I'm starting this, and you know, haven't taken place yet. And the system is still running. I'm still seeing writes to the system. And in a few seconds, no day is going to go down because we need to upgrade it to a new system. Notice that while I'm doing that, we still have writes, proper writes here. The system is operating, but no days down. The key from our perspective is that from the point of view of the user, you don't notice anything. There is a fail request that happened to node A. We automatically recover, move to the other nodes. If we go and look at the behavior here, node B is currently the one in charge. By the way, I can add all sorts of tasks to the system. Right now, the only task that I have is automatic backup. But there's a whole wide variety of things that I will talk about in a few minutes. But the idea here is that this is completely managed for us. At this point, there is no need to talk to any DBA. Let's see if this is up already. It might be. Apparently not yet. Oh, okay. So it's still there. Oh, up again, up again. And now you can see that we are at 4 cores, 16 GB, accepting writes. In a few seconds, this one is going to go down. And my expectation is that the entire process is going to continue. This system is going to continue running. And again, I'm going to go here and just let it run. Node C is the currently the one in charge. Node B is down. We will detect that in a few seconds. Probably we can see it. We detect it in a few seconds. And the system will continue to operate. That leads to a few interesting behaviors. First of all, growing the system up and down is trivial, can be done on a live system with no impact. The entire behavior of the system is based around the idea that I don't expect users to give me much attention. I like to say that RavenDB is a very boring database. It's a boring database because it doesn't need your constant attention. It doesn't need you to keep, are you okay? Are you okay? It's not needy. That's, I think, the best term to describe it. In addition to this, I already spoke on some of the features that we have. We talked about time series. Time series, by the way, is a new feature in the 5.0. And we've tested this. We have it here in Notepad. We tested this with data set that exceed 6 billion entry points. So if I'm looking here at time series, you can actually see that I may, in this case, this is the stock market price for particular duration. And you can have multiple values, track them over time. Again, plot is not really that interesting. Let's do it on a 5-day period, 6-day period. Currently, this is a extremely volatile. Let's see, you want the average of the high. Here we go. I would not sure that I would be eager to invest in something like that, given how the up and low of this thing. Anyway, so the idea here is that you're able to very easily decide what model you want. Okay, this is a JSON document that can represent any arbitrarily complex dataset. That's crucial because it means that instead of having to split your data into multiple tables and joins and a whole bunch of other stuff like that, you can just make things work. But you can still see that there are a lot of additional interesting details that we can use that are important. Let's see what happens when I'm using that. For example, I have company and employee. So from orders were shipped to country. So it would help if I actually spell properly. Okay, so try to imagine how you would do something like that in your application. You don't want to just say company or employee. You want to show the name. Okay, so now I have to do companies 28A. Now I have to do 60, etc., etc. This is incredibly common. This is something. So I'm going to. Oh, I already have this. No need to call that. I already no need to call that. So most of the those are the things that, but also need 4, 7, and 3, 5, all of those. So this is called select n+1. It's incredibly common and horrendous for performance. With RavenDB, I can do this. I'm telling Raven, hey, you know what? When I'm getting the results, go ahead and get me the reference documents. Here's those companies. Here's the relevant employees. So in one query to the server, I can get everything that I want. It doesn't stop here. We also have the ability to do something like this. I don't need all of this data. I need something like there we go. So here I'm doing the projection on the server side. I can also do things like this. And manually control exactly how I want to project the data. There's a lot of capabilities that are unlocked by the kind of things that you have. By the way, I want to repeat, if you have any questions, please ask me. I'm trying to cover a product that I built for over a decade in under an hour. And that means that I'm going to probably have to skip on some of the more interesting things.
We don't have any questions for now, okay?
No questions?
No questions for now.
Okay. Anyway, by the way, let's go to Node C. I think that at this point we have finished upgrading the entire cluster. You will notice that I haven't actually paid attention to any of that. Things just booked. You know what? I don't think that we need that much space. I'm going to go the other way around. And I'm going to do that again. I don't expect the system, I don't expect this to fail. We keep writing. What is interesting is that you can see that the limiting factor is not the system. We keep being very clear at around 100 writes per second. And this is because RavenDB is very efficient. The limiting factor from our perspective is the number of times, the number of requests that my system can return and the latency to Paris. And this is going down, and we'll see how it works in a few seconds. Now, let's talk about some of the other capabilities that RavenDB has. For instance, using the Northwind database, I'm going to go here and add an ongoing task. Ongoing task is something that RavenDB does. And in this case, I'm going to say, okay, here's a query. All of those people are in London. Now, this is a subscription, and that's actually quite interesting when you think about it. What is a subscription? A subscription is a way for us to register for notification from the server. So Northwind, and we can ignore this. Now going to store.subscriptions. And actually probably don't want dynamic here. I want an order. So let's go here. So here are all of the model classes. So I can just put order here. Now, worker.run. Come on, for some reason, I don't get IntelliSense, which means that I keep forgetting what the values are supposed to be. And in this case, first, good enough. Oh, it's not orders, it's employee. Okay, so now I'm going to run this, and that would actually fail because this one is still running. Yes. And this is a task, so I have to wait. So I'm going to run. This is going to start printing some data, hopefully. By the way, the system is currently unstable. I will remind, not this one, sorry. This one. This is currently unstable because I just moved it to a much smaller system. But you can see that this is running. But why didn't it stop? And the reason it didn't stop is quite interesting. Let me just do something minor. I'm adding the employees to the list of revisions. Now I'm going to go and update. Okay. Margaret lives in Redmond. I'm not seeing her here. What if I change it to London? And in a couple of seconds, I'm supposed to see it here. This I would expect to see her here. Let's see. Okay. Okay, that makes sense. We have failure in the system, but let's see. We are currently, the current owner of the subscription is Node B. Node B was down, as you can see here. Let's see if it's back up again. It looks so. Here is Margaret. And now let's go back here and let's change another employee. Now he's already in London. And maybe also in London. Everyone is in London today. Here we go. So we have Nancy also changing her to London. And before I was able to switch windows, you can see me you can see that it already showed up. And you could see that even though there was failure on the other side, we just recovered. There was no error handling. Now, subscriptions are very simple. They are a way for you to handle business logic in a reliable manner. You define some form of a query. In this case, this trivial one. And then you start getting that. Now, what happens if this dies? I'm just going to kill it. And while this is running, let's go and create a new employee in London. Remember, this is not currently running. I'm going to run this again. We can see that in a few seconds, we're going to get the new employee. 1, 2, 3, pretty please. Here we go. So what happened was that a subscription is something that is running constantly, except when it isn't, but it's still able to get those details. And that means that I have a reliable way of getting some things from my system with minimum amount of fuss and effort. If my client crashes, if my server crashes, no worries. This is a reliable transmission. Now, I have one last demo that I want to show you. And this regards the ease of use in which we can update the system. And this is something that I'm really proud of. Let's say that I want to do this. Notice that I'm just writing JavaScript here. RavenDB allows you to work with JavaScript directly to modify and work with the system, which makes things a whole lot easier for us. And I'm running this, and oh. You know what the problem with JavaScript? You don't get, you might get stuff like that where this is probably not good. Yeah, that's not good. Now, here's the problem. We're not talking about a database that has non-trivial amount of data. Time to run for backup. Almost. Let's see what I can do. Remember that I enable revisions. Here's what I'm going to do. I'm going to tell it, go back in time, 1 minute, no more than that. Let's see what's going to happen. I ask you to go back in time. Oh, we didn't finish going back in time. Let's give it a second. Back in time, as things should. Again, the whole idea is that you don't have to worry. You got something that covers it. There are a lot of other features. I think that we are about to run out of the hour that we have scheduled for this. Some of them are about replicating to other locations. Right now, we actually have replication enabled. Remember, we have 3 nodes in the cluster. But you can also replicate to different locations. You can push data to a relational database for reporting purposes. You can push some of the data to another RavenDB process for things like microservices, data flows, for doing things such as sending data from production after cleanup to a QL environment, those sort of things. The last thing that I want to talk about is this. RavenDB has the ability to enable database compression. Let's see what this means. What this means is that if I'm going to go here, most of the data that I have here is in this table. It's not too bad, 700 megabytes. But I enable compression, and now I'm going to tell the database, you know what? Let's make this happen. Sorry. Let's disable not on indexes right now. Here we go. Now, beforehand, the amount of data that I had on orders was about 700 megabytes. And, oh yeah, it's running. Well, it would run, that's expected. There we go. That's what I was missing. So it was about 700 megabytes. Now when we enable compression, oh, this is funny because we also have revisions on order, but we let it run. RavenDB is actually going to compress the documents. Now it's not going to compress them individually. And the reason we don't compress the documents on an individual fashion is very simple. Documents tend to be relatively small. If they are small, it means that you don't get a lot of benefit from compression. You get some, which is nice. But a lot of the repetition actually happens between documents. RavenDB look at the document structure that you have and is able to recognize all of those repetitions and eliminate most of them. I actually had a customer that moved from a collection that was 50 gigabyte in size to 7 gigabyte in size after enabling compression, just because we're able to do cross-document redundancy elimination. We're actually able to do that without having to aggregate documents. So you get the benefit of random access and the benefit of shared dictionaries. I actually had done a webinar on this a few times, and the actual implementation is a lot of fun to look at.
Yes, thank you so much, Ayende, for being here, showing us all of these features and showing us how RavenDB has been stable. And I'm very impressed to see how this kind of database can support applications running, even though the bunch of background tasks running together at the same time is very, very important to us developers and companies that are deciding to choose the RavenDB as database, as the NoSQL database. And yeah, it's a very, very amazing and awesome NoSQL, right? And yeah.
If there is any question
I think so. We have a question.
One question that I see, but before that, just to point out, notice that after the compression has run, the size of the orders went from 700 and something to 268, which is almost 1/3 of that. So in what scenario the replication to another cluster is useful? So try to imagine that right now I'm running in Paris. I want another cluster. I want to run in the States. So I'm going to create one of those, and now I have two clusters in different data centers. I can set up replication between them as two separately independent clusters, but they're going to share the same data. It's very common that you want to do that if you're running on multiple regions, because you don't want to go over the network to a different data center each time. Another reason that you might want to do that is this feature. I want to have an offsite copy, and that offsite copy of the data might be for, if a meteor goes on my data center, I have in a location for that. And it also, you can set it up to be in a delay. So if, for example, you just kill it and if you just kill it and for example, I just did this. Okay, say bye-bye to your data. Then I also have the other copy of the data in the offsite that is hours out of date, and things just work for me in this fashion. Let's kill it. We don't need that. So that's one of the common scenario for that. I think there is another question about whatever RavenDB has been used in Brazil. Yeah, we actually have quite a few people using that. One of the major clients that did that is a company called RDI. I think that currently they were purchased by another company. I'm not sure what the status here, but they are. Let me see. They actually did. They actually talked about this, and if I will be able to find it. Yeah, go. They deploy to 36,000 locations worldwide, but the actual company is, let's see if I remember this. Here we go. So this is the webinar. You can just search for RavenDB 36,000. And they've been using RavenDB for many, many years. 2.5 is circa 2013, just to give you some idea. And that's one of the customers that we talk about. And Mateus as well, apparently, is also using RavenDB.
It's just an appointment that saying us that the company that he was working in use RavenDB as NoSQL database is a good news to you. I think so, Ayende.
Yeah. So that's it. That's RavenDB in 1 hour.
Yeah. So one more, thank you so much for being here, sharing your knowledge on RavenDB and show us all the new features. And yeah, see you in the next webinar. Bye.
Thank you. Goodbye.